Jessore, Higher Maths, 2017, question number 2. In question number 2, we're given a function p of x equal to x cubed minus 6x squared plus 11x minus 6. And we're asked to determine the ratio of degree and leading coefficient of p of x. Now to solve this, in part A we're given px equals x cubed minus 6x squared plus 11x minus 6. The degree of an equation is the highest power of the variable x. So p of x has a highest power, x cubed, so the degree of p of x is 3. The leading coefficient is the coefficient of the term which has the highest power. Now in this case it's x cubed. There's no coefficient in front, so it means the coefficient is 1. So the ratio of the degree and leading coefficient is 3 to 1. In part B, we are given if the remainders of px upon division by x minus m and x minus n are the same, where m is not equal to n, then show that m squared plus mn plus n squared minus 6m minus 6n plus 11 equals 0. To do this, we're going to use the remainder theorem. Now the remainder says when dividing a function such as px by x minus m, then the remainder is pm. So if we have the same remainder when dividing by x minus m or x minus n, we have pm equals pn. Substituting in, this gives us m cubed minus 6m squared plus 11m minus 6 equals n cubed minus 6n squared plus 11n minus 6. Now if we take all terms over onto the left-hand side, that leaves us with m cubed minus n cubed minus 6 into m squared minus n squared plus 11m minus 11n equals 0. Now we can factorise m cubed minus n cubed as m minus n into m squared plus nm plus n squared. We can factorise minus 6m squared minus n squared as minus 6 into m minus n into m plus n. And we can factorise 11m minus 11n as 11 into m minus n. We have m is not equal to n, so m minus n is not equal to 0. Now as long as m minus n is not equal to 0, we can divide all the way through by m minus n. So if we cancel that out, we're left with m squared plus nm plus n squared minus 6 into m plus n plus 11 equals 0. Or expanding that out, we get m squared plus nm plus n squared minus 6m minus 6n plus 11 equals 0. And that is what we were required to prove. Now in part C, we were asked to express x cubed over px as partial fractions. So we have x cubed over px is equal to x cubed over x cubed minus 6x squared plus 11x minus 6. But to divide something into partial fractions, the degree of the top, the numerator, must be less than the degree of the denominator on the bottom. Now we can do this by division, but I'm going to use a different method. On the top we've got x cubed. Well, I can write on the top x cubed minus 6x squared plus 11x minus 6 plus 6x squared minus 11x plus 6. Now the minus 6x squared and the plus 6x squared will cancel, the plus 11x and the minus 11x would cancel, and the minus 6 and the plus 6 would cancel, leaving it as before with just x cubed on the top. But then we can split that up into x cubed minus 6x squared plus 11x minus 6 over the same thing, plus 6x squared minus 11x plus 6 over the same thing again. So x cubed over px is equal to 1 plus 6x squared minus 11x plus 6 over x cubed minus 6x squared plus 11x minus 6. We shall now put this remaining fraction into partial fractions. Now the first thing we need to do is factorise the denominator. The denominator is x cubed minus 6x squared plus 11x minus 6. And we can use the remainder theorem to find the factors. If function of a equals 0, then x minus a is a factor of function of a. So if we try p of 1, we get 1 cubed minus 6 times 1 squared plus 11 times 1 minus 6, which is 1 minus 6 plus 11 minus 6, which is 0, and so x minus 1 is a factor. If we try p of 2, we end up with 2 cubed minus 6 times 2 squared plus 11 times 2 minus 6, which is equal to 8 minus 24 plus 22 minus 6, which is 0, and so x minus 2 is a factor. And if we try p of 3, we end up with 3 cubed minus 6 times 3 squared plus 11 times 3 minus 6, which is 27 minus 54 plus 33 minus 6, which is also 0, and so x minus 3 is a factor. So the factors are x minus 1, x minus 2, and x minus 3. So our fraction 6x squared minus 11x plus 6 over x cubed minus 6x squared plus 11x minus 6 can be written as a over x minus 1 plus b over x minus 2 plus c over x minus 3. Now we can put those three fractions on the right hand side over a common denominator, and we'll have on the top, on the left hand side, we've got 6x squared minus 11x plus 6, and on the right we have a into x minus 2 into x minus 3 plus b into x minus 1 into x minus 3 plus c into x minus 1 into x minus 2. Now this is an identity, so it's true for all values of x. So if we choose x is equal to 1, on the left hand side we have 6 minus 11 plus 6, and on the right hand side we have a times minus 1 times minus 2 plus b times 0 plus c times 0, which gives us 2a is equal to 1. In other words, a is equal to a half. Now if we let x equal 2, on the left hand side we have 24 minus 22 plus 6, and on the right hand side we have a times 0 plus b times 1 times minus 1 plus c times 0. And that simplifies to minus b equals 8. In other words, b is equal to minus 8. If we let x equal 3, then on the left hand side we have 54 minus 33 plus 6, and on the right hand side we have a times 0 plus b times 0 plus c times 2 times 1. So this gives us 2c equals 27. In other words, c is 27 over 2. So x cubed over px equals 1 plus, now it's a half over x minus 1. That can be written as 1 over 2 into x minus 1, minus 8 over x minus 2, plus 27 over 2 all over x minus 3. Well, that can be written as 27 over 2 times x minus 3. So our solution is x cubed over px is equal to 1 plus 1 over 2 into x minus 1 minus 8 over x minus 2 plus 27 over 2 into x minus 3.